Hi, welcome to Tercen. In this video, we'll explore some basic features and get started with data analysis. First thing, let's get oriented. After signing up for Tercen, you will land on your home screen. This is the breadcrumb. It is a pathway that shows where you are in Tercen. Each step is clickable, making navigation easy. If you get lost, simply click the home button to return to your starting point. These tabs organize your screen into projects, the teams you belong to, and an activity log. Click any entry to jump to the change location. The search bar can be used to find projects, workflows, and data files. A project is a folder or repository that holds the data files, pipelines, and supplementary documents involved in an analysis. Press the New Project button to create one. Give it a name. Let's call it My Tutorial Project. You can add a description. Search will look for keywords in the description. Set a visibility level on your project. Public is visible to everyone in the Explore section. Private is visible only to you or your team. We've created an example data file for you to use in this tutorial. Download it from the link in the description. When that is done, open it in a spreadsheet to examine the files. This dataset includes 127 unique patients with multiple immunophenotype measurements taken at different time points during the experiment. In Tercen, columns are converted into factors. Think of factors as pots of data containing everything in a column. Factors can have different types of data, such as identifier codes, which are unique IDs for patients, samples, and many other things. Experimental information. This is supplementary information such as age of a patient or the date a measurement was made, and measurements are the important numbers in a data set. These are what is calculated and graphed. In this file, the main measurement is called value. It is expressed as a percentage of cells in the sample. Okay, back to Tercen. Click Import Data to upload your file. Note there are many file types supported by Tercen. Choose the CSV importer since this file is a CSV. Drag and drop your file or browse to upload. Tercen converts your file into a dynamic table, which enables flexible data relations and visualizations. We can use dynamic tables to combine data files even if they're normally incompatible. You can recognize the file data with some tracking codes Tercen has added. Use the breadcrumb to return to the project. A workflow processes data through visualizations and calculations. Click New Workflow and name it Example Workflow. Your organization may have predefined workflows for specific tasks. We won't select one this time, just press Next. This is the workflow canvas. To bring in data, click Add Step. Choose Table and add the uploaded data. We will build a pipeline by adding analysis steps to it. Click the table to open the local toolbar. Select Add and choose Data Step. It will open automatically. The data step is the main engine of analysis in Tercen. The left panel has the column names from the data file. These are the previously discussed factors. Using your mouse, click and drag value out onto the screen. Don't drop it just yet. The areas where you can drop it light up in green. In the center is the crosstab grid. The x-axis and the y-axis project numbers, while the rows and columns split and group those numbers. A projection is made by dragging factors into the crosstab grid. Drag value to the y-axis. Projections display your data visually and also submit it for further calculations. The central part of the crosstab is called the data cell. Unlike a spreadsheet, Tercen data cells can hold multiple numbers. All of the values are here, ordered from lowest to highest. We recommend that you start every projection by placing your main measurement on the y-axis. Drag cell subset to the x-axis. You've made a simple projection. Adjust the crosstab grid by dragging the black lines. You can zoom in and zoom out by holding the Control key and scrolling with your mouse wheel. Return to the workflow canvas and rename the data step using the local toolbar. Call it Simple Projection. Let's make some data groups. Add a new data step to the table. The data cell will split or merge depending on how the factors are added. Make this projection: value to y-axis, sex to column. The crosstab now has two data cells, each with its own x and y axis. Drag out age. A black line appears indicating that it can be dropped above or below an existing group. Drop age below sex. Row groupings can be made too. Drag cell subset to row and panel type to before cell subset. This creates multi-level groupings. The outermost factors group first and then subgroups work inwards. Columns group top to bottom and rows from left to right. Drag subject ID to below age. Now we have a data cell for every measurement. Use drop zones and the toolbar to control visuals in the grid. Drag value to colors to make a color gradient. Click the Style button and make it a heat map. Take a moment to move the black lines and zoom in to examine the data. Try to look for immunological patterns. Tercen has more color settings in the Palette tab. Experiment with the choices on offer. Take a snapshot by pressing the Download button. This saves a PNG of the crosstab. Be aware that it only saves what it sees, so adjust the black lines to get all your data into the image. Don't forget to save and rename your step. Operators are used to manipulate data in Tercen. They're standalone computer programs written by a bioinformatician and can range from simple calculations to complex control panels and specialized graphs. Click the data table and add. Use the tags to filter. Search for mean and standard deviation. It's added to the toolbar, waiting for a projection. Operators receive data from the crosstab projection. They need the projection to be configured according to their internal design, or they'll not run properly. To discover the projection an operator expects, click the version information link under the operator's name. This will take you to the operator's GitHub page, where layout instructions will be available in the README file. Input defines the layout that the operator expects on the crosstab. This operator requires a number, your main measurement, on the y-axis. Output lists the new factors the operator will create to hold the results of its calculations. This one will create two new factors, mean and SD, and we see it calculates per cell. Let's go back to Tercen. Project value to the y-axis and run the operator. Press the results button to review its calculations. It has calculated the mean and standard deviation of all the values in the cell. Go back to the crosstab. Be aware that when an operator runs, it locks the crosstab grid. If you want to make changes, you'll have to reset the operator and run it again. Let's group data further. Drag cell subset to row and sex to column. Rerun the operator and check the results. Now there is a mean and standard deviation calculated for each of the data cells. Save and return to the workflow canvas. We can visualize an operator's results with a downstream data step. Add a new data step. The Tercen AI will attempt to predict the projection you want to make, but let's clear it for the purposes of this tutorial. See, there is a new folder. We have the original data and a folder with the new factors created by the operator. Project mean to the y-axis, cell subset to the x-axis, cell subset also to the colors, and change the style to bar. Okay, let's save and name this one bar graphs. Operators can generate visualizations as well as factors. To get more comprehensive and featureful graphs, use the plot operator. Let's add a plot operator to our data. When it opens, clear the grid. Make the following projection: mean to y-axis, cell subset to row, sex to x-axis, sex to colors, standard deviation to error bar, and change the style button to bar. Operators can have settings to fine-tune how they work. The plot operator has many settings. Let's change some of them. X label to patient group, Y label to cell type, title to mean and SD graph, wrap 1D to false, and split cells to true. Now press run. Graphs can be downloaded together in a zip file or individually. Let's save the step and check out how the plot operator builds a report into our workflow canvas. Tercen can combine data files and form a relational database inside your workflow. Data tables can be joined together with a key. In simple terms, a key is a match made between two tables because they both contain a column with the same data in it. Usually this is an identifier code, such as patient ID or sample ID. When we examined our data file earlier, we noted it had a factor called experiment ID. Let's join it to an example annotation file. You can download the second file from the link in the video description. Open it in a spreadsheet. The file contains the drug condition for our experiment. It also has an experiment ID identifier code. Let's upload it and add it to our workflow. Add a joint step from the local toolbar. Connect it to the example data table by clicking the nodes. Now edit the step. Pick the key from the list of factors. Press Run step. To verify the join, add a data step to the join. Project experiment ID from both folders into row. The crosstab will show the matches that it's made. If the key was incorrect, the experiment ID from the join step would be blank. To project joint data, add a downstream data step. From the example data file, project value to y-axis, panel type to row, and from the join, treatment group to column. Let's call this one condition. You can use the Tercen projection to build new datasets using factors. These can be exported easily and are useful for extracting simple data from complex files. Add a new data step to the mean and SD step. Clear the grid. Perform the following projection. Cell subset to row, mean to row, and SD to row. Building an export table is one of the rare cases where the y-axis is not used. Press the Tables button and view the data in the projection. Go to the Rows tab and select Download. A CSV file will be created and downloaded to your desktop. Until this point, we've used a file with a single main measurement called value. But what if a file has more than one main measurement? It is possible to convert the format of the data to allow this. This involves changing your data from wide format to long format. Wide data is the traditional table format that you would see in a spreadsheet. Rows are individuals and columns tell you information about that individual. We get to a piece of information by visually cross-referencing the row and the column. Wide data is easy for humans to read, but it's difficult for computers to read. Long data is a list format with one measurement per row. Any experimental information or identifier codes are repeated as many times as needed. Computers work faster with lists. The conversion process to change wide format to long format is called a gather. Download the example multi-measurement file from the link in the video description and open it in your spreadsheet. It is a wide format data. Click the tabs at the bottom to see color coding to show how the data will be rearranged during the gather. Each measurement will move to an individual row, and its column header becomes a label used to describe it. The non-measurement data is repeated as many times as needed on every row. Note that two new factor names are created: variable for the group of labels and value for the group of measurements. Upload the example multi-measurement file to your project and add it to the workflow canvas. Note, this file is an Excel file. Remember to look for the correct importer. Add a gather step from the local toolbar. Open the gather step. Use the plus buttons to add the channels to the list to be gathered. Leave subject ID, age and event ID to be ungathered. They will be repeated on every row. Click the Run Step button. To project gathered data, add a downstream data step. We see the new factors. Value is a group of all the measurements, and variable is a group of the labels used to interpret them. Make this projection. Value to y-axis, variable to row. From the example multi-measurement file, open the More folder and project SSCA to x-axis. Tercen will build a bivariate plot of SSCA against each of the gathered channels. Filters are a way of narrowing down the data projected by the crosstab grid. Use them to control what is shown in a graph or sent to an operator for calculation. In Tercen, a filter is a list of rules built up in the settings. Each rule has three parts: the factor it's based on, logic for the rule to use, and a piece of data to define the rule. Scroll down our crosstab projection. See, there is an irrelevant plot where SSCA is being compared to itself. Let's create a filter to remove it. Drag variable and drop it on the filter zone. The filter settings screen will open. Change the name to Exclude Channels. To remove the SSCA channel, we will build the rule as follows. Variable is the factor, not equals the logic, SSCA a definition. You can use the search icon to find individual data in a factor. Click OK and check the crosstab projection. SSCA is gone. You can reopen a filter to modify it by clicking the Filter Zone chevron. Multiple filters can be created on a projection, and filters can be made more complex with multi-line rules. We'll exclude outlier values from the projection with a filter range. Drag value to filter. Call this one upper and lower bound. Build this rule. Value is the factor, greater is the logic, 0 is the definition. Press plus to add a line. Build a second rule. Value is our factor, less than or equals our logic, 10,000 is our definition. Press OK and check the projection to see how it has changed. Be aware that filters apply their rules from the top down. The top rule is applied first and the next one and so on down the list. The rules at the top do affect the rules that come after them, so it is possible for an earlier rule to exclude data you expect a later filter to operate on. Return to the workflow canvas and name the step Side Scattered Plots. We will conclude this tutorial with a look at teams and link sharing. Anybody can create a team and add new members. People can be added by their username or their email account. Any projects created while inside the team will be visible to everybody in the team. Every location in Tercen has a URL reference. They're shown in blue text. To bring a colleague to an exact spot in a project, copy the URL and send it to them. Remember, they'll need to be a member of your team to be able to see it. Now you should have the basic skills to navigate Tercen and start your data analysis. Feel free to go to the Learn section where you can search for help articles and tutorials, or click on the chat widget to contact us directly. Thanks for watching.